This is a recording of me reading the CPUP Issues in Physical Science, Activity 93, The Nature of Waves. I made a reading guide for you, and you should follow along with my reading and take notes in the reading guide. Sound is only one of several kinds of waves. Some small waves carry small amounts of energy, such as the waves you observed in the long coil on the floor, a whisper, or gentle water waves. Other waves transfer tremendous amounts of energy, such as the energy transferred in earthquakes, tsunamis, or gamma waves. There are waves that humans cannot detect directly, even though some of them carry a lot of energy. In this activity, you will learn more about the nature of various kinds of waves. You will also learn about how certain devices have extended human sensory capabilities. The challenge question is, what are the properties of certain kinds of waves? Wave media. No matter what kind of wave or what amount of energy it transmits, it is important to note that when waves transmit energy, the individual molecules or particles in the medium are not transmitted. In other words, the medium does not move along with the wave. A medium, the plural is media, is the material in which the wave energy travels. Mechanical waves, such as sound or seismic waves, move through the ground, water, air, and other materials. For example, when making waves in the long metal spring in Activity 91, longitudinal and transverse waves, the metal of the spring was the medium. The disturbance moved away from the source. The coils of the spring temporarily moved up and down, or closer together and farther apart, but the spring did not undergo a permanent change of position relative to the source. In this case, the medium itself, the metal of the spring, was not transferred from the wavemaker to the other end. Stopping to think number 1. What is the medium for an ocean wave? Provide evidence that the medium is not transferred when a water wave moves on a lake. Stop here and complete the questions for this section. Pause the video and return to it when you've finished the questions for this section and stopping to think number 1. Two major kinds of waves. In Activity 91, longitudinal and transverse waves, you investigated two fundamentally different kinds of waves, longitudinal and transverse. A longitudinal wave is one that transfers energy through compressions and rarefactions in the medium through which the wave travels. Sound is an example of a longitudinal wave. When you hear a sound wave through the air, you are detecting a disturbance in the pressure of the air. When the pressure is increased, the air molecules are pushed closer together into a compression. When the pressure is reduced and the air molecules move farther apart, it is referred to as a rarefaction. A longitudinal wave is one that causes the medium to move parallel to the direction of transmission, or propagation of the wave. A transverse wave that travels through a medium is the result of the medium moving perpendicular to the direction of propagation. The long coil used in the previous activity was an example of a transverse wave. Light is another example of a transverse wave. Stop here and complete the questions about longitudinal and transverse waves, including drawing a picture. The diagrams on the next page will help you to draw your pictures. Make sure you label all of the things outlined in the reading guide. Stopping to think number 2. How is a transverse wave different from a longitudinal wave? Again, pause the video and resume once you finish this question. Transmission of waves through various media. Mechanical waves, such as earthquakes, sound waves, or waves in a coil, will travel differently depending on the medium. The same wave will travel at different speeds through two different substances. In general, waves travel faster through materials that have springier molecules and bonds. This means that sound travels that sound moves faster through solids than liquids and faster through liquids than gases. For example, sound travels about 5 times faster through metal than through air. Because sound waves always involve the physical disturbance of atoms or molecules, they are referred to as mechanical waves. A mechanical wave must have a medium in order to travel. Mechanical waves cannot travel through a vacuum because there are no atoms or molecules in a vacuum. Although outer space is not a perfect vacuum, the molecules are so far apart that they do not allow the production of compressions and rarefactions. Therefore, sound cannot travel in space. Some waves, however, do not require a medium and can be transmitted through a vacuum. For example, light travels through the vacuum of outer space, whereas sound does not. Because light waves do not require the presence of atoms or molecules, they are not considered to be a mechanical wave. Light is a transverse wave that carries electromagnetic energy. This energy in light waves travels about 900,000 times faster than the energy carried by sound waves. Wave speed. Every wave has 4 basic characteristics: frequency, wavelength, amplitude, and speed. Wave speed, measured in meters per second, is the distance traveled by a certain feature on the wave, such as a crest in a given amount of time. The speed at which the wave travels depends on what type of material it travels through. Sound is transmitted through the air at about 340 meters per second. The exact speed depends on such factors as the temperature and humidity of the air. The tables on the next page show the speeds of sound and light through various media. Although light slows down a little in air, it still travels about 900,000 times faster than sound. This is why you will see a lightning flash long before you hear the sound of thunder from a storm several miles away. Stopping to think number 3. What does it mean if you hear thunder and see lightning at almost the same time? Pause the video after you've had a chance to look over these tables and answered the questions in this section. Extending the senses. Although our world is full of sights and sounds of waves, there are many waves our sensory organs cannot detect directly. However, people have invented devices to detect waves having frequencies that fall outside our range of hearing and vision. These devices include cell phones, radios, X-ray film, radar, and sonar. Each of these devices receives energy from a wave that we cannot detect and converts it into something we can see or hear. Radar works by sending radio waves from a radar source to the surface of a target, such as an airplane or a cloud. The waves are reflected back to the radar source, and the location or speed of the target is calculated from the measurements. Radar systems are based on radio waves or microwaves. Sonar works in a similar way but relies on sound waves at frequencies that are not detectable by human ears. Sonar allows personnel on ships and submarines to detect the depth of water and the presence of fish and other boats on or under the surface. Seismic waves are low-frequency mechanical waves that move through the earth. They are caused by such events as explosions and earthquakes. By measuring seismic waves with a seismograph, even those waves that are not felt by humans on the surface of the earth, scientists locate earthquake epicenters and create maps showing regions at risk of earthquakes. All these examples illustrate ways in which people have invented devices to employ the energy of waves to hear things we wouldn't normally hear and discover things we wouldn't normally see. Stopping to think number 4. What is another example of a device that uses waves to extend our senses? So this is the end of the reading. I have another video for you to watch, which I have the link to it in the reading guide. You don't have to complete this stopping to think question for my class, but if you want to, you can make some notes in there. Make sure after you're done filling out this part of the reading guide that you move on and you complete the analysis. You only need to do analysis 1, 2, and 3 because the video that you're watching and the notes that you take for that will cover analysis question 4. Thank you.